Hey everyone, Chang here and welcome to my channel. Today we're going to talk about permutation. Now this is one of the few key topics that actually uses factorial. Now I went over an entire video on factorial, so I'm going to put a link in the description down below. Now the other topic that uses factorial a lot is combination. The difference between the two, even though it's extremely confusing, is that combination order doesn't matter. So the idea that, for example, if you're drawing, I guess you could say, colored marble from a hat, right? Whether you draw green first and then blue, or blue and green, doesn't matter. The combination itself is that you have a blue marble and a green marble. So notice that the order itself and how you actually get the marble, that's just an example, doesn't matter, right? So that's combination, and we're going to go into detail on combination in another video. Today we're going to focus on permutation. Now, if you can guess, combination, the order and how you get the actual result doesn't matter. Permutation, it actually does. So this is talking about different ways to arrange or get a specific result, but then the order of how you got it actually matter. So in the example that I just mentioned, if you get a green and then a blue versus that you get a blue and then a green, that's actually two different things in permutation. But combination, that counts the same thing. So we're focusing on permutation today. Now, this is a classic example of a problem that is asking you to solve regarding permutation. If there are 10 people in a competition, how many ways can first, second, and third place be chosen, basically? So notice this, the order actually matters on how you chose, right? Each and every one of those 10 people are different. So if you chose the first person, and then the second person, right? That's different, right? So in this case, we're trying to see first, second, and third. Remember, there are 10 people, so I'm just gonna, better way. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Let's just say, for example, if you chose this person as first place versus you chose this person as second place, and then you flip it, this person as second, this one is first, that's two very different results. That's permutation. So let's look at this. We have 10 people in a competition, right? And then we have to choose first, second, and third place, or how many ways can we choose it? Well, guess what? For the first place, there's all 10. So we're just gonna have 10 possibility, right? The second place, right? There's one person's already chosen. So that person's first place, doesn't matter. Now you have 9 other possibilities. So you would multiply by 9. And guess what? The third place, since you have 2 people chosen already, the one for first place and one for second place, you only have 8 people left. So you have 8 possibility. And just like that, you already have your result. 10 times 9 times 8. Well, that's 72 times 10 is going to be 720 different ways of figuring out first, second, and third place. Now, remember, I mentioned factorial. So I'm going to erase all this and I'm going to write a formula for permutation. Alright, so I'm going to keep the original problem right here, but let's look at this. This is the formula for permutation. You have P parentheses N comma R, but this one is not multiplication, so don't get that confused. P is a function, right? So it's going to be P of N comma R, where N and R is basically what you're going to plug in. Now, there's another way that you would normally see this as well. It's going to be N and then a P and an R. Once again, this is not multiplication, right? This is just a specific notation on how they, I guess you could say, demonstrate it. Now, the actual formula itself, every time you see either this or this, remember they're interchangeable, is basically n factorial over parentheses n minus r factorial. Now what the heck is n and r? Now n and r are two different things. N, total number of population. Now, usually in a problem, it basically gives you this entire set of number that you can choose from, an entire pool or whatever you can select, right? That's what N stands for. R is basically the numbers that are chosen, the number of chosen. Now, probably a better way to demonstrate it is to use this original problem that we had. If there are 10 people is the total population, right? And the other one is going to be your how many ways can you choose first, second, and third place. That's how the number of chosen. 3 of them, right? Out of all 10, we're choosing only 3. So in this case, if we wanted to use the formula itself, first and foremost, in notation form, you would see it's going to be P, and then the parentheses is going to be 10. Right? Remember, we're doing the population first. 10, comma 3. Or if you want to see it in the other notation, it's just going to be, what is it, 10p3. So notice I wrote the number small. That's usually how it's going to be. Like, it's not going to be right next to each other, so that, I mean, like as large, so that it looks like it's a multiplication. That's what it's going to look like. And basically what it's saying is that you have n factorial, in this case it's going to be 10, right? 10 factorial over n minus r. So it's going to be 10 minus 3 factorial or 7 factorial, right? Let's just do 10 minus 3 factorial so you guys can see it, and then I'm just going to simplify it. 10 factorial over 7 factorial. Now remember, 10 factorial is 10 times 9 times 8 times blah 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 all the way to 1, whereas 7 factorial is just 7 times 6 times 5 times blah 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 all the way to 1. And then afterwards, basically you end up canceling all the ones down here and all the ones down here. And notice that we actually have the end result of 10 times 9 times 8, right? Which at first, when we solved the problem without this whole complicated looking formula, we still got 10 times 9 times 8, okay? So let me just explain the formula a little more, and then we're just gonna, go through problems. All right, so the formula's up here. Now, how is it really structured, and how is it that this sort of solved like the previous problem? And I'm going to use it in the next problem as well. Now, up here, n factorial is basically letting us know the total possible combination of the entire population, right? So remember, basically, we look at the population, we select once, or how many possible options for the first one, then how many possible options for the second one, and so on and so forth, all the way down to basically nothing, right? All the way down until you've chosen the last of the population. But that's not what we want. Usually in permutation, you're selecting out of the entire population some finite or smaller number. So that's where this comes in. This idea of n minus r factorial, the whole purpose of this is to get rid of everything else, because the down here is the possible combination of everything else, right? So let's just think of it this way. For example, we had the 10 and we wanted to choose, instead of all 10, we're just choosing the first 3. Now 10 factorial itself originally is basically the possible combination of all 10 participant. Possible combination of all 10. 10. Now, 7 factorial, possible combination of, guess what? The 7 that were not selected. 7 not selected. Okay? And so, if you get all the possible combination, and you get rid of all the combination where the 7s are, the other 7 that are not selected are, then what you have remainder, or what you have left over, is basically the 3 that are selected, right? The combination of the 3 possible selected, which was the first, second, and third place. Now, let's look at this one really quickly and see how we can, I feel like reasoning is a lot better than actually using the formula. So for example, how many ways can we rearrange the letters in 4? Now, 4 has technically 4 letters, right? F-O-U-R. Now, let's think of it this way. For the first possible letter that we choose, we have 4 possible options. So it's going to be 4. Right? After you picked one of the 4 letters, you only have 3 letters left. Well, guess what? That's 3, right? Then, after that, you have 2 more choices. Then, whatever's left over is left over. So you only have one way of choosing that one left over. So there it is. This is your final answer for this problem. A very simple problem. Technically 4 factorial, or if you want to multiply it out, is 24. Now, if we were to use this formula, and hopefully when I talk through it, it makes a little more sense, but I'm a little iffy about it. I don't really like it that much, but let's just see. So basically it's going to be P, total population, or total of possibilities for, out of the 4 possibility you're choosing for, or if you look at it in this notation, it's just going to be small 4 with a P and then another 4 right here, and then we're plugging it into the formula. 4 factorial over n minus r. 4 minus 4 factorial. Now, in the factorial video, I mentioned that there was this one thing that when I learned factorial, I actually had to memorize, and I was trying to find an actual explanation, but The explanation I found, I didn't quite, I guess, agree with, or like I didn't really want to accept. Now, the idea is that there's a 0 factorial. 0 factorial, when I learned it, was to memorize it as 1. And when I was looking up the reason why they say 0 factorial is 1, the most believable explanation is actually talking about permutation. The idea that, remember, the factorial is how many different ways of rearranging. 0 factorial means that how many ways can you really rearrange 0 items, no item at all. Well, technically there's only one way, right? And that's nothing. So that's why they say 0 factorial equals 1. And I accept that a little more than some of the other explanation I've seen. Let's just say that. All right, so in this case, what happens? Well, if we plug it in, we have 4 factorial over 0 factorial. And if you memorize this or you accept that explanation, this is basically 1. So that's just going to be 4 factorial, right? And then that will still be 24. And just like that, notice that by reasoning it out, it makes so much more sense than using just the formula and memorizing the formula. I personally prefer, especially with permutation, just to reason it out. It saves you a lot more math, especially, I mean, this one is easy. The other one is a little easy. Let's look at the next one where you actually have to do a little more computation and then see which one you would prefer. All right, let's look at this problem. You can pick 5 numbers for a lottery ticket. The choice you have are the numbers 0 to 6. How many different ways can you arrange the 5 numbers? Now, when we look at the choice, basically 0 to 6, 0, 1, 2, 3, 4, 5, 6. There's actually 7 choices, right? 1, 2, 3, 4, 5, 6, 7. 7 total choices, including the 0. Now, if we wanted to reason the problem out, which is what I actually prefer, right? It's quite simple. Out of the 7 population, or 7 total population, right? The first choice, you have 7 different options. Afterwards, since you use one of the numbers, and remember in lottery you really can't repeat numbers. So the next number you have 6 possible options, then you have 5, then you have 4, then you have 3. And then if you compute it, that's all the possible different ways you can rearrange the number. I think that's fairly simple. Now, if we were to use the formula, basically we have our population, right? And then we're doing the permutation, and then out of the entire population, we're only choosing 5. And then if we follow the formula, it's basically going to be 7 factorial over 7 minus 5 factorial, which is just 7 factorial over 2 factorial. Okay, now, are they the same thing? Yes, they are. Keep in mind that 7 factorial is basically if I were to choose all 7. That's the different ways of rearranging all 7 of the numbers. The 2 factorial, this right here, the 7 minus 5 factorial, is basically excluding the combination of the 2 numbers that I'm not going to end up choosing, right? So notice this. I can pick 5 of the numbers. There's 2 of them that is not going to get picked. This right here, the dividing of the 2 factorial is just basically, the 2 factorial is the combination of the 2 numbers. So out of the combination of all 7, I'm getting rid of the combination of only the 2 numbers that I don't want, I don't care about. And then whatever's left over is basically the different way I can rearrange that 5 numbers. So this one's easier, right? 7 times 6 times 5 times 4 times 3. If I were to write this all out, it's going to be exactly the same thing, because guess what? 7 times 6 times 5 times 4 times 3 times 2 times 1. That's 7 factorial. And the bottom you have 2 factorial, 2 times 1. Then afterwards you have to, simplify, get rid of the 2 and 1. And what you have left over is just 7 times 6 times 5 times 4 times 3. And that's end up the same thing. And then of course if you wanted to actually compute this, what is this right here? This is 42. This right here is 20, 30, 60. That's 24. And what is that? That's 2520, probably. I don't know, check my math. But it's about 2520, right? And then that's just the different ways of rearranging a 5 number. So hopefully you guys can see that. Your choice. Reason it out or use the formula, the result is still the same. So we've reached the end of this video. So hopefully this actually makes the idea of factorial a little more substantial, a little more something that you can actually grasp and see why it's actually useful to a degree, right? Remember, permutation is one of the two main topics that actually uses factorial. Permutation, the order itself actually matters. So how you rearrange the objects matters. Whereas combination, the order doesn't matter. And I'm going to focus on combinations in another video. But hopefully this clarifies things up. Once again, there's two ways to solve it. There's always the reasoning, which is one I prefer. And of course, there's always the formula, which I think you still need to be familiar with, right? I understand that sometimes just reasoning it out might be easier, or maybe the formula is easier, but the idea that when you see permutation, sometimes you'll see the notation like this, and don't forget, there's also the other notation that's like P and then the parentheses. Once again, the P is a function, not multiplication. And then you have your, in this case, what would it be? The population and then the number of choice, right? So you have two different notations for the formula itself, and you might see that. So I don't want you guys to completely ignore the formula, because if it happens to show this notation, you don't know what is going on or how to compute it, that could be a problem too. Prefer this, know this. Hopefully this video is helpful. Thank you for watching. See you in the next one.